You have written your Spark code, your cluster is running, but the job is crawling. The bill is piling up, and your boss is asking why it is taking hours. Sound familiar? Today, I am going to show you the 5 most common and most costly performance mistakes in Databricks and exactly how to fix each one. We are not talking about minor tweaks. We are talking about order of magnitude improvements that I have used to cut runtime from hours to minutes. Stop burning cash on Databricks. Your default config is the problem. Think about your most expensive job. Chances are, it is slowly grinding away on tiny, underpowered VMs. Autoscale does this to save pennies on idle time, but those weak workers become a massive bottleneck for your data. You are paying for the cluster to spin, yet your actual compute is starved and throttled. It's wasteful. Imagine building a race car, but giving it a lawnmower engine. Autoscale often does exactly that. It optimizes for idle cost, not for speed under load. When your data hits, those tiny workers choke, turning your powerful data pipeline into a traffic jam. You are not just waiting, you are wasting the raw horsepower you have already paid for. Here's your dashboard, littered with idle executors. Your job is running, but it's moving at a crawl. This is the insidious autoscale tax. You sized for the start and stop, not the real work. Open the Spark UI now. See those long, flat task timelines? That's your proof. Your data is waiting in line for resources that should already be there. Ignite your jobs, not your budget. Databricks default settings are sabotaging you. Picture a crowded hallway where one doorway is jammed, causing a massive traffic jam. In Databricks, this is data skew during a shuffle. A single overloaded partition becomes that bottleneck, stranding 99% of your worker nodes while they wait for the one overwhelmed node to finish its impossible task. Let's hunt it down. In the Stages tab, sort by shuffle right size. That lonely task with a massive bar is your culprit. Then, scroll to the event timeline and look for that single, stretched out red or green stripe. That's the skewed task throttling your entire job. You have just found the bottleneck. Now, I'll show you how to defuse that bomb. You will strategically sort your skewed keys, forcing an even distribution. Then, you'll enable adaptive query execution. It watches for this imbalance at runtime and dynamically repartitions the data. Your shuffle will spread evenly across all cores, eliminating that waiting game. Cost and time plummet instantly. Do not optimize your code. Your Databricks configuration is the real bottleneck. Running Optimize isn't a maintenance ritual, it is a precision tool. Blindly compacting files without first diagnosing your data's layout is like repaving a smooth road. You are burning compute dollars for zero query benefit. Ask, what are my high cardinality filters? Target only those hot tables and columns that your workloads actually search on. And here's the dangerous part. Z-ordering only helps if the data is written after you define the columns. Adding it to an existing table is a trap. You are just creating beautifully sorted micropartitions over yesterday's data. New writes ignore it, your queries gain nothing, and you are left paying for expensive vacuums on a dead-end layout. But even if you get the timing right, you are still missing the critical question, which columns? Applying Z-ordering to the wrong ones is just wasting CPU. Picture a filing cabinet perfectly alphabetized by last name when everyone asks for records by birthday. You get zero benefit. So what's the rule? Only Z-order columns that are actively used in filters for massive queries. Stop wasting money. These secret settings make Databricks run 10x faster. And here's the one that silently shreds your budget. You've set spark.executor.memory, but you are missing its lethal partner, memory overhead. Without it, your executors crash, forcing Databricks to spill data to agonizingly slow disk. Your expensive compute grinds to a halt, wasting every dollar. Get this wrong and you pay for hardware that's just constantly failing. You think you are being clever by caching everything, but you are creating a dangerous memory debt. The cache isn't free, it steals RAM from your live production operations. Your executors choke, forcing expensive disk spills and garbage collection storms. That cached data frame? It just became your single biggest bottleneck, strangling your job's performance. Here's how you spot the thief. Open the Storage tab and find your cached data frame. Look at the size in memory and disk size columns. If you see a large disk size, your cache is spilling, it's too big. It's actively crippling your executors. This single view tells you what to drop immediately to reclaim your memory and stop the bleeding. $50,000 lesson: your Databricks jobs are slow by default. Here's why. Think of Spark as a busy kitchen, but every instruction must be translated before the chef can cook. That's the JVM. Photon is your elite chef who just gets it, speaking native C++ and processing entire menus of data at once. It's not an add-on, it is the secret, supercharged engine already in your car. Turning it on is your single biggest performance win. Stop thinking of your data as rows on a disk. Photon sees it as vectors in memory, its native language. This is a computational breakthrough. For columnar formats like Delta and Parquet, and for your core filters, joins, and aggregates, it bypasses the JVM entirely. The result? Consistent, massive speedups. This isn't just an optimization, it's a fundamental hardware advantage you are already paying for. Check that box. Now, the real question is, how do you know it is actually running? Look for the magic in your driver logs. Search for Photon and vectorized operations. If you see them, you are flying. If not, you are still on the old engine, leaving money and time on the table. Do not just enable it, verify your acceleration. Cluster choice and data skew are the two biggest silent killers of Databricks performance and cost. Advanced features like Delta Optimize and caching require diagnosis, not dogma. Use the Spark UI. Enable Photon for immediate speedups on supported workloads with almost zero effort. Run the Spark UI diagnosis steps from slide 1 on your slowest job this week and see which bottleneck you find first.